So we have been talking about spin, okay? And yesterday I just gave you an introduction of quantum mechanical spin, and we have understood that that quantum mechanical spin is basically an intrinsic property of the microscopic particles like electrons, protons, neutrons, even photons. They have the quantum mechanical spin. And I think yesterday we talked about Stern-Gerlach experiment exclusively, and we could understand that why we have what we used to have silver atoms. We have an oven, and then we have the collimators to make the fine beam of silver atoms, and then we use the inhomogeneous magnetic field, and then you have a detector. And what we observe is we have the silver atoms, and we find only two groupings. The screen is hit at 2 points, right? And they had a couple of questions in our mind, like why inhomogeneous, okay? Why we have inhomogeneous magnetic field. And for that, the explanation was that if you give the uniform magnetic field, then these atoms will experience a complete torque, and you may not observe the two portions on the screen which lead to the two types of spins to these silver atoms. And the next important question was that why we are using neutral silver atoms, why we are not using the silver atoms in which you have ejected electrons, and why don't you use ions of silver atoms, right? And for that, the explanation was that a new kind of force will interact with these silver atoms. That force is Lorentz force. So the experimental outcome of this Stern-Gerlach experiment reveals that there are two types of spins. One is spin up and spin down. And our motivation today is basically to come up with Pauli's spin matrices. And I had written down yesterday. I had written down some kets and bras of spin up and spin down. You remember that? So what was that? It was, if I have spin up, if I choose it as, what was it? 1 by root 2, 1 by root 2. And the spin down along x as 1 by root 2 minus 1 by root 2. And then spin up along y as 1 by root 2, I by root 2, and then spin down along y as 1 by root 2 and minus I by root 2. So these are the kets, okay? Now if I write down the bra, so what will be the bra for this? Okay, so you will have, the bra spin up. What will be that? That will be the row vector, 1 by root 2 and 1 by root 2. Clear? Okay? Fine? And the bra for spin down along x will be a row of 1 by root 2 minus 1 by root 2. Right? And then you will have the bra along x, spin up. This is our spin up. And this will be 1 by root 2. And then, because here we have a complex, right? So since when you transform from ket to bra, okay, you take the transpose of that matrix. In addition to the transpose, if it's a complex function, you write down the complex conjugate, right? So here you will have 1 by root 2 minus I by root 2. Clear? And then you have spin down along y, that will be 1 by root 2 and I by root 2. Clear? Fine? Okay. Now we have the last one left. What is that? That is spin up along Z. Yeah, what is that? That is 1 and 0. So if you write down its bra, spin up along Z will be 1 and 0. Am I right? And finally you have spin down along Z, that will be 0 and 1. And this is going to give us, its bra will be I, Z is 0 and 1. Clear? Now let me write down something like this. Now if I write cat of Ix and bra of spin up minus cat of spin down along X and bra of spin down along X. Okay? Now we want to evaluate this. And we will see that this will automatically lead to sigma X. That's a component of Pauli spin matrix, right? Now let's do that exercise ourselves. So what we have cat off, spin up along X. Come on, what's that? I'll write down that here. So that is 1 by root 2, 1 by root 2. Yeah? Times bra. So it will be 1 by root 2.
Minus.
No, there is no minus. This is spin up in both the cases. Come on, look at it. This is spin up cat and spin up bra. Okay? For the bra, you will take what? You will take the row vector of I along X. What will be that? So here, this is 1 by root 2 and 1 by root 2. Am I right? Then what I have? Minus. Yeah. Minus. Spin down. Spin down. What's that? That's 1 by root 2 minus 1 by root 2. And then you have 1 by root 2 minus 1 by root 2. Clear? Fine? Now let's evaluate this. So this will give us 1 by root 2, 1 by root 2, that's 1 by 2. Clear? Then 1 by 2. Clear? Okay? Now 1 by 2 here and 1 by 2 here. Clear? You have minus here. Okay? Now you will go here. So this is 1 by root 2. Sorry, 1 by 2. Because cat and root cancels. And then you have minus 1 by 2. Then you will have minus 1 by 2. And minus minus will be plus. So that is 1 by 2. Clear? Come on. Finished? Okay. So now all I have to do is to subtract the two matrices. So what I will have? So see, I will have here, this is 1 by 2 minus 1 by 2, that will give me 0. Okay? 1 by 2 minus 1 by 2 will give me 0. This is 1 by 2 minus minus is plus, so this will give me 1. And then you have 1 again, and then you have 0. Right? So this is called sigma x. So this is called sigma x. Right? So sigma x is what? So sigma x is 0, 0, 1, 1. Clear? Now let's go with what should the basic formulation for sigma y now? How do you think? Because if you go back, how I wrote down the equation. Where is that? This is our equation. Okay, it has led to sigma x. Now if I have to write the same thing to obtain sigma y, what will I write on the screen? Come on.
Y.
Very good. Yeah. You're right.
Yes, y.
So there is a way to reach the loss. Okay. Now, come on. So now, what should I write? I think I should write up y cat and
Y bra.
y bra. That's correct. Minus down y
bra.
cat and okay.
Down.
I have to write cat first. Okay. So this has to be the cat. Okay. It has to be like this, and then bra of spin down along y. Right? Now let's evaluate this. Okay. So what is this? This is 1 by root 2.
Minus
No, it's I
I by root 2. I by root 2.
I by root 2. There. Fine.
Multiplied by
Now
1
what
by
about this? This is
1 by root 2. I by root 2.
1 by root 2.
I by root 2.
It's minus I by root 2.
No,
Okay.
sir, इसमें columns भी change होते हैं.
Not only columns, you have to take the complex conjugate. Right? So I will give us minus I by root 2. As I told you before. Okay? So here you will have minus. Come on.
1 by root 2.
1 by root 2. Yeah?
Minus.
It is kept along down, so it is minus I by root 2. Okay? This is a column vector. And the row vector here will be 1 by root 2. Minus will turn into plus. So this is I by root 2. Clear? Okay? So now all I have to do is to multiply them. So we have to go with the matrix multiplication. So I think I'll use another page for this. Okay, 1 by root 2. So what I'll have is, can I keep it here? Let me write it here. So this is what? This will give me 1 by 2.
Yes, sir.
And this will give me minus I by 2. Okay? Then this will give me I by 2. And this will give me iota square will be minus 1, minus minus will be plus. So it will be 1 by 2. Clear? So here you will have minus. Come on. So this is 1 by 2. Clear? And then iota by 2. Fine. Now minus iota by 2. And then this will multiply with that. Iota square will give me what? Minus 1, minus minus will be plus. So here I will get what? Plus 1 by 2. Fine? Okay, now let's move on from here. So do you remember this? Tell me about it. Okay, so what I have got? I have got
0.
See, now this will be 1 by 2 minus 1 by 2. This is going to give me 0. Okay, fine. Minus I by 2 minus I by 2. So this will give me minus iota. Right? And this is
Plus iota.
this is plus iota. Exactly, this is your
0.
and 0. What is this? This is sigma y. Let's check it from the book. So this is
Sigma y.
sigma y. Right? So we have obtained sigma x, we have obtained sigma y, and we have obtained sigma y, and we have to obtain sigma z. And there is another important thing. Okay, you can do that. So what about sigma z? So how should I write the basis? Come on.
Z.
Yes, this is up z ket, then up z bra minus down z ket, and down z bra. Come on.
Yes, sir.
Right? Give me the result. Come on, I'm waiting for you. Solve it. Yeah. Up z, that's 1 0. And then this is 1 0 minus 0 1 times 0 1. Okay. So this will give us 1 and 0 and 0
minus
and 0.
No, minus 1.
Hmm?
Minus 1.
So 1 and 0.
0, 1,
0.
0, 0, minus 1.
No, I'm talking about this part of it.
Okay, yes, sir.
So it has to be 0 here.
Yes, sir.
Then you will have minus here, okay?
0,
After
0,
that,
0, 1.
you will have 0,
0,
0, okay?
0, 1.
And here you will have 0 and 1, okay?
Yes.
Now you subtract the 2.
1, 0, 0, minus
This is 1,
0,
0,
0,
0 and minus 1. Clear?
Yes, sir.
Now, what you should proceed with is I want you to I want you to go with this. You must have known this. Sigma x square is equal to sigma y square is sigma z square. Okay, is equal to identity matrix. Okay, so come on, do it now. Okay, so for sigma x, how much was sigma x? It was 0, 1, 0, 1.
Yes, sir.
Check it out.
Yes.
Okay, then I'll multiply it with 0, 1, 1 and 0. Come on, do it. You should obtain an identity matrix. 2 by 2 identity matrix. Okay, come on. So this is, now this way, if you go this way, this is 0, 1, 0 plus 1, and then this is 0 plus 0, and then this will give me 0 plus 0, and this will give me 1 and plus 0. Sorry. Okay, fine.
Yes, sir.
So you can see this is equal to
1, 0,
1, 0, 1, 0. Right? Now check the same thing for sigma y. Right? So let's see what happens at sigma y. Will you please tell me what is sigma y? Yeah, it is 0, 0. Here is minus I. Is it I here? Come on, nigga. Minus I, and then I, and it's multiply it. So this is 0 minus I and 0. Right?
Yes, sir.
So let's do it now. So this is 0. Iota square will give me minus 1, so this is plus 1. Fine? And then this is 0, and this is 0. Fine? And this is iota, this is 0, and this is also 0.
1, 0,
And going with the last one, iota square will give me minus 1, minus minus will be plus, so this is 1 plus 0. And what you obtain is, you are obtaining the same identity matrix. So by doing this, you are able to confirm that the square of the Pauli spin matrices, that is sigma x square is sigma y square is equal to sigma z square is equal to the identity matrix. So I think here we should stop. Okay?
Yes, sir.
Here we should stop. So we'll meet in the next video. That's it.